students go above and beyond. And hey, he was a little fast on that. What do I need to know on that? But anyway, Celsius is the input, and then Fahrenheit is the output. I've been saying it all year, input, output. But in this equation, Fahrenheit is the input and Celsius is the output. And that's what you're going to find out what an inverse is. Equations that are inverses, the input outputs are switched, all right, and inverted. So that's what's great about this. Those that are taking old-fashioned notes, don't write any of this down. But this is the vocab, and because of the time, these are words that I'm going to be talking about throughout, so I don't need to reiterate that. You can read it if you want. All right, we're going to move on because of speed. And I guess on this first one, I'll probably ask less student stuff because we only have 40 minutes left. That's not that bad, actually. Okay, so gaining an understanding. You know what? I think I do have time. Forget that, man. I'm going to, lose my responsibility. 25. Who's that? Who got the first? Damien. How do I solve for y? Do we have Damien here? That's great. That's the wrong class. I'm a maroon. Sydney Stewart. Sorry, I was looking at period 2, not period 3. Darn it, Sydney. I just said your name on the internet. You can sue me now. All right, anyway, Sydney, what do I do first? Absolutely. So I think we've had questions like this before. This is called a literal equation. No, you don't need to know that. Don't worry about that. And then what do you do last, Sydney? Okay, good. I think we have time for that. Go ahead and turn off your mic. You're done with that, unless your name gets picked again. All right, and then you can distribute that division. That's really how you handle that mathematical situation. All right, next students say, oh, hey, look at this, Sydney. It's your lucky day. Okay, what do I do on the next one? Oh, Sydney, by the way, I'm going to call you out on this. There was a whole chapter on how to solve y squared. Solve for y. What would you do on that? Not, yeah. Mm-hmm. Square root both sides. Not a whole chapter. There was a section where how do I solve for y squareds? By the way, Sydney, this is wrong so far. Do you remember the little condition you got to deal with when you square root both sides? Little thing. Absolutely. Good. Well done. Turn off your mic. Unless the calculator loves you today, you're done at least on that question. All right. So don't forget about square rooting both sides. You got to put a plus minus, certainly. Okay. So I'm going to put some words here. And again, if you're an old-fashioned note taker, you're writing them on a piece of paper. All you got to do is write these 3 words. It's super fast. And if you're sitting there doing nothing and not taking any notes, that's why you're failing or struggling. Yes, I'm going to be aggressive on that. Some of us laying in our bed just taking nothing. This internet stuff and this e-learning. Anyway, independent variable is the input. I'm just going to put a bunch of synonyms. The independent variable is always considered the domain. Now, some teachers might hate that I do this, but most of our equations are in terms of x and y. So let's really think about that. And then, of course, we know that the x is considered the domain, the input value. I've been saying input, output all year long. That's another part of my infinite sadness. There's some people that still on that last quiz cannot graph by inputting, outputting. That just tells me you can't do basic math. You can't take a square root of a number and can't even think about that. And that's where my discouragement comes in. Dependent variable is the output. Of course, we know what's the opposite of domain, not the opposite, but range, domain and range. And then, of course, when it's XY equations, usually the Y is considered the output. All right. Just a real quick example of what's called a function. And I guess I'm going to look at chapter 2. I thought we talked about function, domain and range, input and output before, but you definitely did last year. So there's no doubt about it. You know these terms. Making money. How many people have a job? I'd be curious if anyone really does. Okay, got a couple. 1, 2, 3. And usually your job is hourly, right? Like, so you get paid per hour. Raise your hand if that's the case. Okay. So if someone asks you how much money do you make a week? And usually your answer would be, well, it depends. It depends. It depends upon how many hours I work. See, the independent variable every week could be how many hours that you work. How much money you make depends upon how many hours you work. There's a function right there, a function of how many hours you make, depending upon depending on how many hours I work, depends upon, or how much money I make, depends upon how many hours I work. Sorry. So there's a dependent, independent, input, output. The input is how many hours you work. The output is how much money you make. So when I have an inverse relationship, we invert or switch the input outputs. I think I put a little different definition because all these are so synonymous. We switch or invert sorry, that looks like a W, that was a bad, domain and range. So I think that's kind of what I put in the other class. Another word for switch is exchange. So that's what Mrs. Cooper says, your possible future Math 3 honors teacher. She says domain and range exchange when we talk about inverses. And we'll talk about that as we move along, but we'll take this in this first simplistic example. So I'll do the first one, and then those for the, taking old fashioned notes, just do a quick coordinate or a chart, sorry, and then put those X, Ys. Those that printed, put f of x up here because I want to also do something else or tell you something about um, inverse notation. Create the inverse relation. Determine if the relation is a function. By the way, relations just like the word you think it is, related. This x coordinates related to this y. This x coordinates related to this y. 0 is related to this 3. They're connected. So that's why the word relation is used in these situations. Okay, hide that. Now create a new chart. And then this is where we're going to give you some notation for inverses. I didn't really want that line to go there, but that's fine. Go forward. Can I go forward? Guess not. That's what I'll do is this. This gives those that are taking old-fashioned notes some extra time. What is the notation for inverse? And I'm going to go back and put this up in the word definition. Inverse notation looks like f to the negative first of x. So now I'm going to go back up to my box for inverse relation. F of x, inverse of f of x equals this notation. That's something else you're going to want to see and understand and know moving forward, in this class and actually in the Math 3 honors. Not sure, I looked at the homework today, but I forgot to look, do they use that notation in the homework or not? If they do, you must be ready for understanding that means inverse. And we're going to use that throughout the whole note. So after this, if you don't know that, I don't know what's going on. Okay, 1, 2, 3, 4. This is Mickey Mouse. Okay. Oh, and by the way, I just found out that we have to determine or at least define what a function is. Oh, I could have swore we did this year. Second hour was like, oh, and I thought we talked about it in chapter 2 all the way back in August or September. So I'm going to relook at some of the notes and see if we did and then pull them up. Not to blame you on anything, but just say, hey, we did, just hopefully you do remember it. But you definitely did last year. All right. So here's the inverse of this. It's so simple. You just switch X and Y. You invert them, you change them, you flip them, whatever word you want to understand. 1, 1 becomes 1, 1. No change. Be ready for that if your number gets called today. Because that's a big concept of understanding, do I have the inverse or not? Okay, now here's this next sentence. We got a problem. Determine if the relation is a function. Huh? Here's the simplistic definition of a function. I remember when I was a student, probably in your seat right now, maybe a sophomore, maybe a freshman, was the first time I got the definition of a function. I was like, what? I don't quite get it because the definition was very mathy. So as a math teacher, I simplified it. You have a function, quite simply, if in your relation or set of coordinates, there is no repeating x values. That's it. That is a function. If you have a relation where you have no x values that repeats in the situation. Okay, and that's really the simplistic, truthful definition. I don't know if another math teacher would be mad that I put that simplistic definition there. I just remember students and me as a student hating, the definition of a function and understanding it too well. Hey, student number 2, Matt. With that being said, does this box of coordinates, this relation, represent a function? Yes or no? Absolutely not. Okay, then I'm going to explain something else then. This is not a function. What's the reason, Matt? What coordinate screws it up? Yep, you have a repeating x value here. Of course, Matt, over here, we have a repeating y. But Matt, is this a function over here? Yes or no? Yes or no? Yes, this is a function, but I want you to write this down because this is actually later with the other tests of something being a function or not. When it has repeating y's, it's said to be not one-to-one. And all that means is the repeating y aspect. So notice when a function is not one-to-one, when I find the inverse of it, it's not a function, the inverse. And that's a relationship we're going to hammer here. So again, hopefully, I know you've heard the word function before and it's been defined, student number 3. Gracie, let's call this one g of x just because that's another power of function notation. We can name functions differently. And then I'm not going to write x comma y. We know the top is usually, I guess I will. I'll do my chart this way because charts can go that way, and x is on the top and y is on the bottom. And Gracie, I'm not going to ask you this. What's the inverse of g of x? 2, -1, not one, -1, 2. -1, 1, -1, 2, 0, 4, 2, 6. Wax on, wax off. Karate Kid. Gracie, function or not a function, this g to the -1st of x or inverse of x? Good. And then I hope you guys remember this. I hope you do remember this from last year. I don't know if I did it this year. I should have checked in between classes, but that's the reason. So, of course, that means g of x, the original function, is not one-to-one. All right, so we're going to exercise that as we go through this. That's why math is a ladder. If you're sitting there not taking notes and not focused on what's going on here, and your number comes up, we're going to wait for you. Okay, 19, Emily Ann. Oh, just be ready, Emily Ann. Sorry, wasn't ready to pick a student there. Okay, so what's an inverse function, or what are we going to do when we find the inverse of a function or an equation? What we're going to do is we're going to do a domain x and range y exchange. Now, I'll be fun. I think this is a funny story. I worked with Mrs. Cooper when we taught pre-calc honors together for a year. That was a great year, by the way. And I would say, well, I always say switch X and Y. And she's like, ooh, I don't like that. She would say domain and range exchange, and that's what I've taken from her. I say that now so that when you hear her next year, you'll remember that terminology. But exchange, another word for exchange is switch. So what you're going to do when you find an inverse equation of an equation, you're going to switch x and y and then solve for y. That's why I already forgot who it was, that bell work where we solve for y in equations. But then we're going to change y to the inverse notation. And I'm going to wait till, don't write that in words. We're going to wait to a question and when we actually do this with an equation. All right. And I'm going to take a long definition on this one. The graph, and we'll see this in every example today, of a function. This is a better definition than some of my other ones I've shorthanded. And its inverse are always symmetric. I think I have a little better definition than last hour. The words are a little bit, they just come out of my head. With respect to, I don't think I used those words last hour. With respect to the y equals x line. So now we got to know how to graph lines. That's why math is a ladder class. I think in my CAT class, I was talking about, here's a ladder. Here's August, September, October, November. If you didn't do squat in August and September, that's why you're struggling in November and what were the October? I couldn't remember the months. All right. So knowing how to graph a line is going to come up again. By the way, y equals x is the same thing as y equals 1x plus 0. What? Why would he do that? Hey, student number 19, Emily Ann, what does that mean the slope of that line is? Y equals x. What's the y-intercept? Correct. And that's all we got to say about that. Is that all you get to answer on, that's kind of easy. Okay. All right. So, hey, why don't you graph this? What's this a graph of on this example too? What is the picture of? And then we'll leave it. We'll have you answer two, hopefully easy questions, which is a picture of you just describe what type of function it is. What's the picture called? Starts with a P. I'll give you a hint. There you go. Yeah. Quadratic just describes what type of function it is. I don't know where that word comes from, by the way, but that's fine. We just use it continuously. But it actually graphs what's called a parabola. Input output. I'm not putting a chart over here. If you don't know how to input output at this point, you're severely behind. You're missing so many ladder rungs. You're missing them from last year. Arr, he's so mean. 1 squared is 1. 2 squared is 4. -1 squared is 1. -2 squared is 1, 2, 3, 4. Boy, I got some high level questions here. Like, sure, that's a parabola. Input output work just great. Is this parabola 1 to 1? Hey, put that in the chart. It's a yes or no question. Is this a 1 to 1 function? Yes or no? This would be interesting how many people, and don't be worried if you put the wrong answer. Good, I got some yeses. I should do like wish I could do a poll. I think I can do a poll. Dang it. I think that is something cool. I could think about that. Oh, a lot of yeses. Don't feel sad. It's actually a no. Remember what one to one functions are? They're functions that don't have repeating y values. You see that? There's repeating y values in this. So it is a function. There are no repeating x's, but there's a whole bunch of repeating y's. And you're going to find out that there's a problem with this. But anyway, we're going to continue. Find the equation of the inverse, determine if it's a function. So this is a function, but we got to find the inverse. Next thing, I'm going to do this as an example, so I'm not going to bother a student. First of all, f of x is the same thing as y. It's just a fancy different way of naming a name, all right, of a function. And then we're going to switch x and y. And go ahead and look up at the bell work. Isn't this what, I forgot who it was. I'm sorry, I usually remember who did what question, but isn't this what we already solved for, right? And all we had to do in order to solve for that is square root both sides. And then, of course, from the bell work, the student caught it. Was it you, Gracie? I think it was. I'm just trying to remember names. Not remember names, remember who did what. This is what I want you to do that ties these two functions together. Reinsert a name for y. Because notice I took f of x, which is just another way of writing y, and turned it into y. Now call this the inverse notation f of x. So the inverse of f of x equals the plus minus, oops, my brain tried to do two things at once there, the square root of x. And then what that does is ties these two together. So f of x is this. This means the inverse of f of x is this. All right, and then we could go from there. And then doing a chart of values actually should not be that hard. We have graphed square roots. We just haven't graphed plus minus square roots. Watch what happens. Well, nothing special with 0. When I plug in 0, I still get 0. So that's right there. Can I plug in -1? Let me see your head shakes. Yes or no? Can I plug in -1? Yes or no? Move your heads. Absolutely not. It doesn't graph in a real world coordinate plane. So I don't know why I put 0 so low here. I got 0, 0. Square root of 1 is 1, but then plus minus. Oh no. In the chat, is the inverse of f of x a function? Yes or no? No, 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 no. And that's what you're starting to get here. The next good value to plug in is 4. But now you're going to see 4, the square root of 4 is 2 and -2 because of this plus minus. So 1, 2, 3, 4, comma 2 and -2. And now we got this picture. Oh, by the way, back to you, Emily Ann. Oh, I had so many questions asked of me. What is the slope of the y equals x line? What's the slope again? What's the y-intercept? 0, 0. And then how do I use 1? What do I do? How do I move? There you go. Up 1 over 1, up 1 over 1, up 1 over 1. And then I'm going to make this a dotted line because it's not either of those two graphs. What I'm going to do is make that statement that I put right here, line of reflection. The graph of a function and its inverse are always symmetric with the y equals x line. Look. Sha-na-na-na-na-na-na-na-na-na. By the way, this is the sound I make for symmetry. Sha-na-na-na-na-na-na. Sha-na-na-na-na-na-na. Oh, look at this one all the way across here. Sha-na-na-na-na-na-na-na-na-na-na-na. Those are all mirror images over the y equals x line between the red graph and the blue graph. Oh no. Notice the red graph is not 1-to-1. What did he just draw there? And the blue graph is not a function. And what I just drew was a horizontal line and a vertical line, because that's one of our next things for when we're looking at a graph. How do I know if it's a function? How do I know if it's 1-to-1? So on and so yeah, so we're just going to move on from there. But anyway, I don't want to jumble your mind too much there. Shouldn't be too bad. Input output, been doing it all year long, right? Understanding what happens there. Okay. Student number 26. Nice. Who's that? Patrick. What's the slope of this line? We're going to graph this first. And then what's the y-intercept? Tell me where to move my pen first. Do I use 2 or do I go, what do I do to graph this line? Which way? Up, down, right, left? Sorry. There you go. And then how do I use 2? What do I do? Up 2 over 1. I just realized I didn't look at my directions. Up 2 over 1. Sorry, I have to go back and clean up that last example. So Patrick graphed the line. Sorry, stop. Let's switch gears. I didn't answer this question. Graph both the original and its inverse as well. Determine if the inverse is, is a function. I did not do that. The inverse of f of x is not, we already did say that, a function. What I was trying to get into is a test for that, so I forgot to write that down. Right, just kind of knowing the next question. We're going to ask the same questions. Good, Patrick, you're done. Just worried about people and understanding how to graph lines. John or Jack, sorry, you're up next. Okay, how do I find inverse? I am in blue here. What do I do with this equation? Absolutely. I'm going to do this little thing with you guys all in this little section. When I say inverse, you say switch. There you go. So this turns into X and this magically turns into Y. Jack, I hope you take your notes. Look at the bell work. We already solved for Y on this one. We subtracted 1 and divided by 2. So it was, 1/2 X, right? Minus 1/2, correct? What's your y-intercept on this one, which is kind of a pain, but we're still going to handle it. Which way do I move? Up, down, right, left for that? Yeah, some people mess up y-intercepts and make them x-intercepts. Tell me how to move for 1/2. Like, how do I do the next point? I go which direction 1? And then which direction for 2? Right 2. Another thing you should know that this is a positive slope, so it should rise as we read left to right. That's another discount double check. All right? That when I read this line left to right, it goes up, as far as the y-axis is concerned. So positive slopes, that happens. Okay, you're good. And then I'm going to draw it again and then see that these two are reflections over the y equals x line. Why am I drawing that as a dotted line? Because it's neither of those two graphs. So it's not really the graph that I'm dealing with. Oh, by the way, sorry, I do want to call this the inverse of f of x now. Get used to that because that is notation that is solid as a rock. I don't know if this book uses it. If it's not, then it's deficient a little bit. Well, I don't want to rip on it, but they're just, we're doing the basics of it, but we want to get you everything in your head here. Okay, and then Jack, just one more question. Is the inverse of f of x a function? What do you think? You see any repeating x's? Oh, yeah, it is. Yeah. The inverse of f of x is a function. Basically, all lines, unless they're vertical, are functions. Okay, so that is definitely a function. And I'm going to show something next that will help you with graphs and understanding that. So the homework is very specific. I actually, put those directions in there in line with the homework. So they do want you to do all these things. Just making sure you got that going. So I actually said this last hour a little bit earlier. Before this situation here, I'm going to prove this thing. What's the vertical line test do? If a graph is crossed only once, and then this will help Jack because he had a tough question. He had to think a little bit. Is this a function or are there any repeating x's? If a graph is only crossed only once, by an infinite amount of vertical lines, I'm probably saying this is a little bit off. I should say by each of these infinite amount of vertical lines, then it's a function. Watch our last two that we determined from our chart that they were or were not functions. So let's go back up to this blue one. Hey, look at this. Here's this blue parabola. And when I draw one vertical line, it crosses twice. Boom shakalaka. That is proof that I have repeating x's. So that vertical line tells me that that blue graph is not a function. This is synonymous. These are the same thing going on here. The chart proves it. The vertical line test proves it. And that's why I put that chart of values there to really solidify the vertical line test as far as determining functions. Then look at Jack's. Vertical line, vertical line, vertical line, vertical line, vertical line, vertical line. Jack, an infinite amount of vertical lines. Each vertical line is only going to cross your graph how many times? Once. That proves that there is no repeating x values. Okay? All right. So that's the vertical line test. The horizontal line test, see, this is note taking 101. If a graph, what is he doing, is crossed only once by an infinite amount. Oops. Those are little parentheses. Remember I told you about that, I think it was you guys. Maybe I talk about it with my um, cat classes a lot. This is note taking 101. Sometimes definitions almost have all the same words except one. Horizontal lines. Then the function, it's still a function, is not 1-to-1. And then we're going to make a really big point about this. And we're worried. We don't know if you had this last year or not. I thought we talked a little bit about this in our other class. But let's look at the red graph. Look at this red graph. I think we said that that red graph is not 1-to-1. That was what we put in the chat. Notice when I draw a horizontal line, I have a function because it does pass the vertical line test. You know, the vertical line test is still good, but it fails the horizontal line test. And then lo and behold, look at what happened when I found the inverse of this non 1-to-1 function. The inverse is not a function, all right, because it fails the vertical line test. Notice up here, this passes the horizontal line test as well as the vertical line test. So this is 1-to-1. Notice the function happens when I find the inverse. All right. And that's the relationship between functions and non-functions when we find the inverse. It depends upon the original question. So what happens is if we have a lot of words to define here. This is why we kind of run short on the notes, but we got to set all this stuff up when we talk about inverses. These all have to be in our head. If we have a function that is not 1-to-1, we can, the pen, we can restrict the domain so it is 1-to-1. Now I ask this, I'm gonna tell you right now. I feel like this is one of those real math things where kids are like, who cares? You know, but if you get into calculus, I asked a calculus teacher, Mrs. Wilson, like why do we care so much about things being functions and so on and so forth? All I'm going to say is there's reasons when you get into calculus why we really want to be dealing with functions and inverses that are functions and all this other stuff. So just lock that in if you're going to be one of those students that go that far and want to be, you know, in some sort of high level career that deals with math. All right. So I just got that to say about that. What that does is ensures that the inverse of that restricted domain function is a function. And we're going to see that. I don't want to put that in words. So notice what we have here. right? And hopefully if you printed the notes, we're ready to roll along. If not, just going to give you a minute to take this, and then we just have 2 more examples after this. So notice if I do a chart of values, I'm going to do this on purpose. -4, -1, 0, 1, 4. Okay, 0 squared, 1 squared, 2 squared, and then I'm going to draw this. And on purpose, I'm going to draw it like that. And then I'm going to take this other part, -1 squared, -2 squared. And then, of course, this is the same example that we had that we've already done. But then, oh, wait a minute. What's this? This is what's called the restricted domain. You are restricting what you can plug in for X, because then I'll show you what happens. And I'm going to finish that off. That's the restricted domain. Oh, so they're telling me that I can't plug this in and I can't plug that in. I can only plug in these numbers and those numbers after that forever. Yay, pen. There we go. Oh, I don't know why I put 4. I'm sorry. I meant to put -2. I just had 4 in my head for the output value. Sorry. 2, comma 4. So I can't plug these in. So these never get graphed or not allowed to. So now I have to erase this part of the graph. Oh, hey, everybody. What does this little part now pass? Don't worry about putting it in the chat. You should know it's horizontal line test. So now when I find the inverse of this, I'm only going to find the inverse of this part of these values and those that go forever after that, of course. That's why I put an arrow on my graph to show that this continues forever. So yes, I'm going to find the inverse of this. I'm going to square root both sides. And then mathematically, Mr. Samuelius yells at me if I don't put plus minus. Oh, but wait a minute. The restricted domain, I don't have the minus part of that square root graph. Now, input output, this does make me sad someone doesn't know how to do this as far as this graph is concerned. 0 squared, I'm sorry, square root of 0, 0. Square root of 1, 1. Square root of 4, 2. So notice 4, 2 in the first function becomes 2, 4 in the inverse. And now you have an inverse that is a function. Because you restricted the domain in the original, now the inverse is a function instead of not being one. All right. Still have that y equals x components of reflection. There is no part down here, but I'll continue the y equals x line down there. So the idea of restricting the domain, so you have a one-to-one function, so the inverse is a function, is the idea that we just demonstrated right there in a real short fashion. Okay, now for you guys, I know I'm going to get this first one done and just expect that we're focusing and understanding. Last hour, it's because of my mic issue for 9 minutes talking to you with my mic off. That was fun. Anyway, everybody should know that this is a little different parabola, and this parabola goes down. So if I were going to graph this, I would know that this is the vertex because 9 down makes 0, 0, now 0, comma, -9. And then everyone might do this, 1 and -1 for input output, but then look at the directions. Restrict the domain to produce an inverse that is a function. And we're actually going to find this inverse and graph it. The second one, not as so much. Oops, sorry. So 1 squared is 1. 1 minus 9 is -8. Same thing happens with -1. If you're still squaring negatives and getting a negative, you're a button pushing, non-thinking. This is why you struggle with basic math. Wait a minute. That function is not one-to-one. So I'm going to restrict the domain again where I will not plug in those numbers. I am only going to plug in numbers from 0 to infinity for x and really consider this part of the graph and not the other part of the parabola. So yet again, my restricted domain is just like the last one. I will only plug in values that are greater than 0. All right, and then because of time, I'm going to go ahead and find the inverse of this one, and then I'm going to expect my third hour to watch the last few minutes of the YouTube video today as part of their homework, because I'm going to continue with letter B, and then you'll be even with the other hour. And if you don't do that, this is why we are not doing as best as we should. So when I find inverse, I do switch x and y. So we know that this is y. You can skip this step if you get it. I'm just making sure that you understand that means y. So that I can switch x and y. Okay, fine. Domain and range exchange. Add 9. A square root. Now, here's the kicker. And you could skip this step too. It's going to be y equals. You can now call it the inverse of f of x. Oh, plus minus. Here's what the restricting of the domain did for you, though. You don't do the minus part because of this restricted domain. Now, last hour I got to ask them, and don't be leaving when the bell rings anyway. Many of you come 2 minutes after the bell rings here at Lockport. You should all know how to graph the square root of x plus 9. That was our last quiz. It does make me infinitely sad how many people still don't know how to input output. The very first number that I would plug in is -9. Because -9 plus 9 is 0. The square root of 0 is 0. Well, lo and behold, the red graph has 0, -9. The blue graph has -9, 0. Domain and range exchange. X and Y switch. What would be the next one to plug in? Actually, accidentally, 0. Because 0 plus 9 is 9. Square root of 9 is 3. 0, 3. All right, I was a little sloppy with my graph here. This should have been 3, 0. We'll make that real big there. There, it hits 3, 0 there. All right, and then everyone should know this square root graph looks like this. And then if we put a y equals line, y equals x line, then we could see that symmetry happening. If I were to continue that arrow, we have that symmetry as well through the y equals x line. Okay, so I'm going to finish off this example. You might want to stick around because there is 10-minute passing periods to watch what we have going on with this, because this is review. How do I graph this? I got to find the vertex. When we're in standard form, how do I find the vertex? Oh, standard form, ax squared plus bx plus c. Anyone remember this? You should. So when I do negative b over 2a for the x coordinate of the vertex, negative 8 over 2, don't leave me now, pen, 2 times 1, which is negative 4. Then I don't have the time. When I plug in negative 4 squared is 16. Negative 4 times 8 is negative 32. Oh, 16 plus 16 is 32 plus negative 32 is 0. So negative 4, 0 is where the vertex is. By the way, 1's the leading coefficient. This is how the first next points work on that. I think many of you figured that out in the graphing section. By the way, the y-intercept is 16 for that graph. How would I restrict the domain for this in order for this to be a function? I would have to get rid of this part. So the domain should be restricted to only these x values. So the domain should be only x values that are greater than or equal to -4. So I had to find a vertex to find that turning point in the parabola to know how to figure that out. Okay, now listen. It's only 10:22 on my part, or 11:22. To find the inverse of this is beyond our Math 2 level. So to find the inverse of this, you need Math 3. You need some pre-calculus. Because what would end up happening is this. And actually, you know what? I shouldn't sell you short. It's just something we're not going to hold you accountable for. How would I solve for y on that? It is kind of a little bit complicated. You actually do have the math skills to be able to do it, but it's not something that's going to be asked of you. And that's not really what they ask you to do. They just ask you to restrict the domain in this question. So I don't want you to worry about that. Okay? All right. So you can go now. Just reiterate one more time, don't worry about finding the inverse of this last one, because that's not the point of the question. The point was to review that, finding a parabola's vertex, which is something we should remember for, doing our work and stuff. All right, I'll shut up now.